Okay, part 18. We have to solve this equation. I'm going to show you this in two ways. I'm going to show you the proper way that I taught you the first time, and then I'm going to show you a way that's not very intelligent, but if you forgot the proper way, you could use it to get the right answer because it's a multiple choice test. The way you're supposed to, can anyone remember how I'm supposed to solve this? What am I supposed to do?
Make the base number equal and then the exponents.
Sure. Let me make this bigger. He said, yeah, we need to make the base numbers equal. What am I going to do with this 0.2? Make it a fraction, remember? So you could type in 0.2 into your calculator, hit the toggle key, and so you wind up seeing that this is 5 to the x power equals what? This is 1/5. Okay? Now, I need it to just be 5 to a power. So how can I write 1/5 as 5 with a power? Right, 1/5 is the same thing as 5 to the -1 power, which means x equals -1. Now that is the quickest and most accurate way of solving the problem, if you know how to do it. Okay? So x is -1, so looking at our choices here, that means the answer is D. But please understand, anytime you have an equation and then you have a bunch of answers to that equation, what's another way that I could just figure out which one of these is the answer even without really knowing how to solve it? Right, you can always just sit here and plug these in one by one and see which one makes a true statement. So, for example, if I wanted to check answer A, I could write 5, I could put 5 to the 2/3 power in my calculator and see what I get. Can somebody just type this in your calculator real quick? You get 2.29? Okay, you get 2.9 if you put this in. The answer is 0.2, so you would know that A is not correct. You know what I mean? So you could do that for each one. You could write 5 to the -2 power. You could write 5 to the -2/3 power. Your TI-30 will do all of this. So you could check each one and look for the one that gives you 0.2. None of these wind up giving you 0.2 until you get to this last one. And if you do 5 to the -1 power and put that in your calculator, it will probably give you a fraction at first, but if you hit the toggle key, it will give you that 0.2. So ding, 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 you know that one's the answer. So that's two ways to find it. And that works for any kind of equation when you have multiple choices. Good to know, Burton. Good to know. Okay, on the count of 3, blurt out the asymptote of problem number 2. 1, 2, 3, go. 5. I heard about 7 or 8 people say 5. So my people that were silent, do you understand that the asymptote is always going to come from that number on the end? I mean, I'm talking about asymptote and stuff, but it's been a while. Do you guys remember that graphs like this was an exponential function where it was either going to be growth or decay? Is this particular function going to be growth or decay, you guys? It's going to be growth because looking at that 3 on the inside, that's bigger than 1. So we would expect this graph to be a growth function like this. Well, I guess I should have made the asymptote should have been, so let's see. I'm going to do it right now. 1, 2, 3, 4, 5. So the asymptote should be up here, yeah? Oh, that's going to move the whole thing. Let's just start over. So it would be exponential growth. The asymptote would be up 5, so I just wanted to get that back in the front of your brain. But the asymptote, that line that it gets closer and closer to, we can always tell it by looking at the number on the end. So it's, oh yeah, but the way you write it, everybody said the number 5. But how do you write The asymptote. Do you remember?
Y equals 5.
Yes, you have to say y equals 5. It won't just say 5. There might even be one answer that says 5 and one answer that says y equals 5 and another answer that says x equals 5. You need to know that it's just y equals 5 would be the asymptote. Okay, moving on. Looking at these, I'm supposed to tell which one has the greatest value. What would be an easy way to figure out which one of these has the greatest value? Yeah, we could just put them in the calculator. All right, let's do that super fast. Can you guys read me the expressions because I have to switch to the calculator? Expression was. What was the problem? 3 to the negative 9 power. Okay, I forget exactly how it was written. So 3 to the negative 9, like that. Okay, so we got that. That's a really, really small number. We're looking for the biggest? Is that what it said?
Yeah.
Okay, what's the next one? 9 to the negative 5th power? 9 to the negative 3rd power. Okay, so 9 to the negative 3rd power. Okay, again, that's a pretty small number. What's next? 1/3 to the negative 9 power. Whoops. 1/3 to the negative 9 power. Okay, 19,000 something. That's a nice big number. What's the next one? What's the last one? 1/9 to the negative 3rd power. Okay, so what was the biggest value? A, B, C, or D?
C.
Okay, so C was the biggest. So you could just use your calculator to answer that question. Okay, looking at number 4. My youngest daughter was misbehaving. True story, except for the Skittle part. Sorry, Maya, I don't mean to put your business out there. Too late, it's on YouTube. My youngest daughter, Maya, was misbehaving in 1st grade. I knew she loved Skittles, so I told her that on the first day of good behavior, I would give her 3 Skittles. And on the second day, I would give her 6 Skittles. And on the third day, she would get 12 Skittles, and so on. I need an equation that would give me the number of Skittles she would get on the nth day of good behavior. So just looking at a chart that I could make, I'll let n be the days, and over here I'll put the number of Skittles. So day 1, she got 3 Skittles. Day 2, she got 6 Skittles. Day 3, she got 12 Skittles. You can probably see that this is doubling every time. Okay? 3 doubles to make 6. 6 doubles to make 12. Can you guess what the next number would be?
24.
We would bet that on the 4th day, she would get 24 Skittles, and so on. Again, I have all these equations right here given to me. How could I tell which one is the right one? Again, I could put them in the calculator. Let's see. Say if I do C. I'm just going to try C first. 2 times 3 to the n minus 1 power. Okay, so 2 times 3 to the, instead of n minus 1, I'll just put x minus 1 power. All right, I'm just randomly checking options. I meant to put it in a table. One more time. 2 times 3 to the x minus 1 power. Okay, and we need to start off looking at day 1. So, do these numbers match the number of Skittles we talked about? No. So I know it's not C. Which one did you guys decide is the right answer? Okay, can you read me the equation? 3 times 2 to the x minus 1 power, n minus 1 power. Okay, so let's check that. So we look at this. 3 Skittles, 6 Skittles, 12 Skittles. Scrolling down, 24, 48 Skittles. This is following the pattern for the right number of days, the right number of Skittles. So that was D. So that's how we know that D is the right one. Okay, so with the TI-30, this is pretty easy, right? Yeah. Okay, looking at number 5. Again, are you thinking of the 2 different ways that I could solve this? The proper way and the bootleg way. What would be the bootleg way of solving this equation? What's like the kind of cheating way? I could substitute these values in one by one for the x's and see which one's true. Let me do that first this time just for fun. I want to make it a little bigger. So here's the kind of cheating way of solving the problem. I will try out x equals 3 first by plugging in 3 for both x values. That would make this 10 to the 3 minus 3 power equals 100 to the 4 times 3 minus 5 power. You know, I could do some of this in my head. What's 3 minus 3, obviously? That's 0. So I got 10 to the 0 power. 4 times 3 is 12. Minus 5 is 7. So this is 100 to the 7th power. So if you did not know, I mean, you should know right now that this is not a true statement. But if you didn't, you could plug them in your calculator. What do you get if you put, what's 10 to the 0 power? Anything to the 0 power is 1. 100 to the 7th power is going to be a really big number. It's not going to be 1. So it's definitely not A. Okay? So you see what I mean? I could plug these in one by one until I find the right answer. But I'm going to start doing it properly now at this point. Here's how you're actually supposed to solve this problem. Okay? This is what you're supposed to do. Remember what Anoop was telling me earlier. I need the bases to be the same. So I've got 10 to the x minus 3 power. How could I write 100 as a 10 and a power? I could write 100 as 10 squared. What do I do with the 4x minus 5 then? Parentheses, so 4x minus 5, like that. At this point, I can, by logic, I can forget about the tens. And I can just say, okay, x minus 3 must equal, I'm going to go ahead and do the distributive property though, and put 8x minus 10. So this is an equation I can work with. I want to subtract x from both sides to get those x's together. So that's going to give me negative 3 equals 7x minus 10. Then I would add 10 to both sides. And that's going to give me 7x equals 7. Then I would divide both sides by 7. And I would get x equals 1. That means C is the correct answer. And that's really how I would like you to solve it. Certainly in your packet that that's going to be due on Monday, this is what I want to see. But if you forgot how to do this, you could always check your answer by plugging it in and seeing if it made a true statement or not. Okay. Now, here's some notes. Every time I put a bullet like this, see this little cluster of shapes? That tells you that here's some notes for you to remember or learn. So, we talked about inverses, finding the inverse. We looked at reflections. We looked at switching the x and y, solving for y. But here's some more information. If you do the inverse of a linear function, it's going to be a linear function. For example, if I start off with this, how do I know this is linear anyway? Y equals 2x minus 3. I'm saying that's linear. Would you have known that it's linear? What makes this a linear function? How do you know? There's two ways that I think about it. Do you guys remember this? Y equals mx plus b. Y equals mx plus b is the model that you learned for a linear function. So anything that sort of looks like y equals mx plus b is linear. Most specifically, though, focus on the x. See how it's not squared or cubed or anything? It's just plain x. That's part of what tells you that it's linear. It's just a plain x. So anyway, if I did the inverse, switching the x and y, solving for y, it would turn out I would get this function over here. This function is still linear. It's still y equals mx plus b. It's still plain x. So, a linear function stays linear when you take the inverse of it. Now, that's not true for some other types of functions. Let's talk about a quadratic function. A quadratic function is the function that has x squared for the exponent. Okay, you need to know that. Quadratic means with the x is squared, like a parabola. Now, if you take the inverse of a quadratic function, you're going to get a square root function. Specifically, if I took the inverse of this function x squared minus 3, it would turn out to be the square root of x plus 3. So a quadratic function with a squared is going to end up as a square root function as the inverse. I basically want you to memorize that. It makes sense because eventually I'll have to take the square root to unsquare this x, and I'll get the radical. So memorize that. In a similar way, okay, so quadratic becomes a square root if you do the inverse. A cubic function, if you do the inverse, is going to become a cube root function. For example, if I started off with the function x to the third power minus 2, if I were to switch x and y and solve for y, I would wind up with the cube root of x plus 2. So a cubic function will always turn out to be a cube root function. So use those notes to help you answer number 6. Okay, take a few seconds and decide. We're talking about the inverse, right? Which one of these functions is the inverse of a linear function? Alright, so Paige, if it starts off linear and it's going to end up linear, which one of these 4 choices is a linear function still? That's close, except for the fact that it's in the denominator. Can you see one that just looks like y equals mx plus b? A. Function A is the one that is linear. It's still y equals mx plus b. Linear should stay linear, so we're looking for y equals mx plus b. The answer is A. Okay, go ahead and look at number 7. Which function is the inverse of a quadratic function? Yeah, if you were paying attention earlier, the inverse of a quadratic function should be a square root function. So C is the one that's a plain square root function. D was tempting, but it had that extra squared in there, so that's a no because of the squared. The answer is C. A quadratic becomes a square root function. Okay, one more. Look at number 8. Look at these choices. Take a minute to think. Which one of these is the inverse of a cubic function? All right. It looked like everybody understood that the answer was going to be D. The inverse of a cubic function is a cube root function, and D is the only one that is a cube root function. Okay? Now, new information, yet so easy. The next problem will be the easiest problem on the EOCT. All right, we've got this whole story behind it. The cost in dollars of a budget DJ is given by the function C equals 100x plus 75, where x is the number of hours of music played. This is the key right here. I really could have answered the entire question just by looking at what I just circled, nothing else. What does it mean when there's a little -1 on the letter like that? That means it's the inverse. It means it's the inverse. Now, if you were to look back at the paper we did, part 17, we learned that if you take the function and its inverse, the way you're supposed to tell if two functions are truly inverses of each other is if you plug one inside of the other, what should you get as the net result? Somebody was paying attention to the video earlier. Everything was supposed to cancel out and you're supposed to just get x. So notice, x is just the thing inside. So if you have a function and its inverse, the rest of everything around it should cancel out and just leave you with whatever's inside. So by definition, if I have function c and its inverse, one inside of the other, what's going to happen? Everything's going to cancel out, and what's going to be left? 6. Okay, just like we're left with x, we're just going to be left with 6. If anytime you have a function and its inverse, the number on the inside, whatever's on the inside, is just going to be all that's left. So the answer is 6. We don't really need to do anything with the 100x plus 75 or any of that. Okay, so that's the easiest problem on the EOCT. So I hope it'll be there for you. Okay. Number 10. Let's solve this properly. Yes, I could plug each of these values in and find the answer, but let's do it the right way. I need to write both of these numbers as a base 10. Not base 10. I need them to be the same base. What base can both of these be turned into?
3.
They can both be base 3, can't they? So how can I write 9 as a base 3? I can write that as 3 squared. Of course, I still have the x plus 1 to deal with. Now, how can I write 1/3 as a base 3? I can write 1/3 as 3 to the negative 1 power. That means, by logic, the 2 times x plus 1 should equal the negative 1. I'm going to go ahead and do the distributive property, though. So I'm going to write 2x plus 2 should equal negative 1. And then solve from there. But that was the hard part. So minus 2 on both sides. So that gives me 2x equals negative 3. Then I divide both sides by 2. And I get x equals negative 3 over 2. Is that one of my answers?
C.
C. So that's why the answer is C. Okay, that's how you do that. Look at problem number, whatever this is, 11, 11. Look at all those words, blah, 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 blah. Why am I just saying blah, blah, blah and not reading the problem? I heard Mr. Perez say 146. Okay? Easiest problem on the test, right? If you have the inverse of itself, it's just going to be the number on the inside every single time. So 146, next problem. Yay. What else we got? Oh, better zoom out. Okay, so this is going to be true or false. Yeah, problem number 1 is false. This is not increasing over its entire length, because if I were an ant walking along this shape from left to right, I'd be going uphill from here to here. So from there to there, I'm increasing. Alright, but then all of a sudden I'm going downhill. As I go from here to here, I'm going downhill. So any downhill part is decreasing. So that's why this is false. Stay out of those backpacks, children. Problem number 2. There is a point discontinuity at -4. Is this a discontinuity? No, this is not a discontinuity. That is false. Remember, a discontinuity is a gap. It would be like an empty hole there, or some sort of a break. So this is continuous. That's why number 3 is true. This function is continuous, meaning there are no breaks anywhere. It's connected all the way across. Okay? Is this a one-to-one function? Alright, how do you tell looking at a picture if it's a one-to-one function? It has to pass both the vertical line test and what? The horizontal line test. Does it pass the vertical line test? Yeah, it passes the vertical line test. Only 1 point. Only 1 point. Okay? But does it pass the horizontal line test? No, it fails the horizontal line test. Bam, bam, bam. That's a fail. So this is not one-to-one. It's a function, but not a one-to-one function. The domain and range are both negative infinity to positive infinity. Is that true or false? That's true. It goes left and right forever, and it goes up and down forever. That's your domain and range.